Welcome to my video on solving rational equations, part 1. In this video we're going to be taking a look at some simple rational equations where our goal is to solve for the variable. In the past videos we've worked on simplifying when we were adding or subtracting or multiplying and dividing, so we're still going to be needing those skills, but now we're going to be solving for the variables. So if you need a refresher, I recommend you checking out my videos on adding rational equations, or multiplying and dividing rational equations, or simplifying rational equations. So with that said, let's get started with our first example. In this first example, we have x plus 8 over x equals 6. And our goal is to figure out what value of x, or what value does x need to be, so that this is a true statement. And our goal to start off with is to make sure that everything has a common denominator or no denominator at all. So right now I have x over 1 plus 8 over x equals 6. And if this is going to work out, I'm going to need common denominators to add these two pieces together. So, since this denominator is 1, I can multiply top and bottom over here by 1. And since this denominator is x, I can multiply top and bottom here by x as well. And let's take a look at what we get. If I do that, I end up with x squared over x plus 8 over x equals 6. Now, since I multiplied top and bottom, everything is good, and I don't have to worry about the 6 just yet. And since I have a common denominator, I can now add these two together. So this, I'm going to write it up here, becomes x squared plus 8 all over x equals 6. Now we have x's in two different places here. This is an x squared, this is an x. And if we're going to solve these rational equations, we don't want the x's in the denominator. So what we're going to have to do is multiply both sides by that denominator, by x, so that we get rid of it. That cancels out the x on the bottom, and I have x squared plus 8 equals 6x. Not too bad. Ultimately though, since I have an x squared and I have an x term, I'm going to want all the x's on the same side. So I'll subtract 6x from both sides. This gives me x squared minus 6x plus 8 equals 0. And hopefully you notice that, oh, this is a quadratic equation. I can get my solutions by one of two ways. I can use the diamond method of factoring, or I can use the quadratic formula. For this example, I'm going to factor. So, let's factor it using the diamond method. A for the x squared term is 1, b is negative 6, c is 8. A times c up at the top is 8, b is negative 6, so I need two numbers that are going to multiply to 8, positive 8, and add to negative 6, which is negative 2 and negative 4. So this is going to factor down to x minus 2 times x minus 4 equals 0. And to finish this off, I just need to know what values of x make this true. What value are going to make this equal 0? Well, that means x minus 2 has to equal 0, because if that is equal to 0, the whole thing is equal to 0. And if x minus 4 is equal to 0, that will also equal 0. So we get two solutions here. X equals 2 and x equals 4. And we have finished this first problem. Those two values will solve our rational equation. Okay? A lot of work there. Not too terrible, but we had to go through a lot of steps. So we're going to try another example. and we'll see how we do. Alright, for our next example we have x equals 6 over x minus 1. And we can do the exact same approach as we did last time. Our goal is to get a common denominator over here so that we can actually do the subtraction. So I'm going to multiply the 1 by x over x, and I'm going to multiply the 6 over x by 1 over 1. Doesn't need to be a negative 1. That's going to give me x equals 6 over x minus x over x. Now we have common denominators, so we can combine our fractions through subtraction. That's going to give me x equals 6 minus x all over x for both of them. And now we want to get rid of the denominator. To get rid of the denominator, you multiply both sides by that denominator. So multiply this side by x, multiply this side by x. That cancels these x's out, and that makes the other side an x squared. So I have x squared equals 6 minus x. And this is looking like it's going to turn into a similar problem like before. We want it to equal to 0. So I'm going to move the 6 minus x over to the x squared side using inverse operation. So I'm going to subtract 6 and add x to both sides. And I'll change the order just a little bit. So we have x squared plus x minus 6 equals 0. Alright, just like before, we are now at a stage where we can either use the diamond method to factor and solve, or we can use the quadratic formula. This time I'm going to use the quadratic formula, not because I have to, but just to refresh how we do the quadratic formula. And we need to remember that if the diamond method doesn't work, if this was something where you couldn't factor using the diamond method, you would have to use the quadratic formula. So, quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And we can only use this if it equals, if this is equal to 0, and this quadratic formula gives us x values. So what does x have to be to make it equal to 0? Well, a is 1, b is 1, c is a negative 6. So we can start plugging in our values. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 6 all over 2 times 1. That's going to give me, I'm going to work my way down here. It's negative 1 plus or minus the square root of 1 plus 24 all over 2. So I've got negative 1 plus or minus the square root of 25 all over 2. Negative 1 plus or minus 5 all over 2 when we simplify that square root. So we are almost there. We just got to figure out what is negative 1 plus 5 divided by 2 and negative 1 minus 5 divided by 2. So negative 1 plus 5 over 2 is 4 over 2, which is 2. There's our first solution, x equals 2. For our second solution, negative 1 minus 5 all over 2, that's negative 6 over 2, which is negative 3. So there is our second solution. And we have solved both pieces. So there we go. We now have our solutions to this radical equation, or sorry, not radical, rational equation. If x is 2 or x is negative 3, this will turn out to be a true statement. So, with that said, hopefully you found this not too bad, and good luck solving rational equations.